command-driven, like playing a song. So we're all familiar with the Amazon Echo and things like that, right? So that's kind of this simple, natural way of using the force. So some examples of that, you're playing a space game, you're in a SAS, and there's a hatch in front of you. So you might just say to the game, open the hatch. Cool, right? So it opens the hatch, and I'll open the lights because it's too dark, I don't like it. So that's pretty cool, simple interactions, it's quite fun, right? Or in a more productivity concept where you have a VR application for architecture or industrial design. Somebody might be playing with its environment, looking at materials, looking at colors, looking at lighting. The architect might say, oh, let's try this with hardwood floors. Let's see how it looks like, right? Put that in pine, you can change and interact naturally with the environment. So you can imagine having that floor just suddenly change, and you can actually visualize that very efficiently instead of using controls and being, long and boring. So you can really use a rich interface with the voice. I think that's pretty interesting. But I think where it's going to be really more interesting is when you can start interacting with characters within the VR world, right? Having a conversation. Like we were talking about conversational interface in general. I think that's a lot more exciting than just simple commands. Commands is a great start, but we can push that quite further. Anybody seen the movie Her? Yeah. I really like that part. I didn't put the video, but check it out. Her Alien Child on YouTube. It's really, really amazing segment. It's not VR. It's actually mixed reality in this concept. But you see the guy. He's playing a game. That's a game, and he's interacting with the character through voice. And it's a really smart character. It's really AI driven. And the character using cameras actually looks at the world around it and can actually infer things and have a great conversation and put personality. So that's really exciting. That's where you start having those natural conversations. So you can imagine that in the VR world, where you can interact with all these different elements. Another application could be in retail, right? So we've seen Alibaba and ASOS and different companies try out VR. And here the example could be interact with a sales clerk, right? You can say, ask the person to come in and ask questions. Oh, do you have this in brown? Oh, do you have this model? And then the application can check its stock, right? Its inventory, and see if it's actually in stock within the store locally or remotely. You can actually purchase and do a lot of things like that. So that's pretty cool. Not a big retail fan, quite frankly, so that would be my great use case. So what's really good about this is that's actually possible now, right, with existing technologies. That's really sweet. Just to show you how that can be done. Example of using existing technologies. So you've got a Get User Media API, for example, for those that are familiar with interweb stacks. And you can actually use that for capturing the audio or the camera and stream the content directly, right? So that's great. And then you can use in conjunction with some other APIs like the Web Speech API, which Google provides an implementation of for the speech recognition. And then you can actually have the transcript of what a person said, which gives you the text. And you can use that to puppet into an NLU service, which is natural language understanding. And that's where you extract the user intent or the semantics of what people are saying so that you can actually interact and have a good understanding of what people are saying and asking. And you can actually map those intents to actions within your VR world so you can actually interact. Let's say the example of open a hash. Okay, I want to open a hash. Great. So the intent here might be open door, right? And you can extract extra information like the entity within that utterance is door type, in this case, hatch. Why would you do that? Well, if you're looking at a specific scene, there might be multiple doors. You might want to interact with that one specific door, for example. So you can do a lot of fancy things around NLU to extract all the right information and use that to interact with your world. So in this case, you recognize that when intent is open door, you look at what door it is, and then you look at your world, you've got a tagged object that you're seeing in your VR world. You can actually then decide, oh, okay, I've got to animate this object within my scene. You can do that animation and continue the gameplay, right? So it's really a nice way of interacting and controlling your VR world. But again, I think you can push that further, a lot further. And imagine something called contextual conversational VR architecture. That's something I just came up with. I haven't checked it in Google, but let's kind of think about what that might mean. Contextual. Well, imagine being able to interact with specific characters that are in your field of view. So you're looking around, you're moving around, there might be multiple characters, and the person that you're looking at, that's the person I'm interacting with. Right? So your application, your VR app knows that you're actually looking at a person, so that's contextual because it's relevant to you. Right? It's also specific to you. You might know who you are based on your user ID or different things, so that it needs to be about you. Right? And you can also have memory of past interactions. So game or the VR app might track the interactions. So using APIs in the cloud, you can actually store all of that history so that you know, for example, the app might know what you've asked previously, what you're doing now, where you are in the game. So you can actually track that whole information in the cloud and leverage APIs to integrate with that. So that's pretty cool. That's contextual. Now let's look at the other element, cognitive architecture. That's a fancy term for saying it's actually the interaction of AI or machine learning components that together form a bigger system, a more complex system. Right? So if you think back of object-oriented programming, where you've got different modules, for example, different object classes that form together the software system, cognitive architecture is similar in the AI space, where you use different machine learning algorithms, different AI systems, bring them together as a bigger system to form really complex architectures. That's something that exists now. That's actually something we're even looking at. Boomers who's doing some really complex things there. So there's a lot of opportunity. Yeah, it's in the cloud, right? It's not running on your device, so it fits perfectly with WebVR. It doesn't matter. So imagine that you've got your VR character using a cognitive architecture. So one of the main components would be the NLU engine, right? So you're having a conversation with the character. So in context, I'm looking at that character. The VR world says, okay, this is the object you're interacting with. Then you trigger the NLU, so you can have that speech conversation through that system. Then you can add some other elements that make it really smart. So if you think of the alien child on her, it includes memory, it includes visual recognition, face recognition, a whole bunch of stuff. So you bring that together. And one element is the visual exotic memory. So that's tracking, it's a list of events, essentially, right? So for those familiar with anything, sorry, it's getting really nerdy here, but with neuroscience, exotic memory is the memory of events, right? That's what it is. So you can actually build a component in the system that tracks those events within your interaction, and it can be specific to you. Right? So it's going to remember who you are, what you've asked, and all that, like we mentioned before. You can also integrate some semantic memory in there, which is really about the world, understanding what things mean, and how do you interact with things. So yeah, a table of code, you could put something on it, right? So you can push that concept further for gameplay and productive applications. So that's starting to form really a complex system that is really interactive, super exciting, that goes way beyond the looking at a picture or things like that. I'm going to throw in something in there. There's also the concept of reinforcement learning. So I don't know if anybody's familiar with that concept. So that's the field in AI or machine learning in general, where you actually have a goal and the system learns to achieve that goal better and better over time. So you're repeating something by giving it rewards. So if the goal is to, if you take this classic Pong example, the goal is to beat the other opponent. And through reinforcement learning, as you try things, every time you try it, it's going to get better and better at it through rewards and policies and a bunch of stuff. I can answer those questions better if you want. But what's interesting here is imagine that in gameplay where the character is interacting with you, learns about you, how you're playing, and learns how to beat you over time, or becoming better at what they're doing. That's like really advanced elements that you can integrate in that. And that's, again, that's doable now. You need research, you need a lot of funding, obviously, but something that we can actually build right now. Raw data. Has anybody seen that game? It's VR, it's pretty cool. It's not WebVR, but it's great. And imagine being able to interact with subject right here, your co-op partner. can tell that you're planning to do something on your behalf, for example, like a scam. Or you can tell them, hey, go there and kill that person. Yeah, imagine being able to interact in that space. And that's where we're actually getting into. And just recently, a colleague of mine sent me a video. I should have remembered that name. I think it's a new version of Star Command or something like that. So it's a space game that uses speech recognition and cognitive services that are offered through Microsoft. And it's pretty much that. Simple version, but you're actually starting to interact with the characters. You can ask questions, get information on your mission, and really it just rounds up the world, the VR world, like never before. So as WebVR improves, as the performance and the power of devices that power that WebVR, we're going to be closer and closer to the experiences on just portable devices. So imagine that. Today we're looking at spheres and blocks and a bit more complex structures, but in the next few years, WebVR can potentially become this, and very quickly. I mean, if you look at the space of AI in general, it's evolved so quickly, and what I've seen in WebVR, it's evolved so quickly as well. So there's lots of exciting opportunities there. So it's really a cool space to be in, lots of innovation. So definitely a space to watch. That's it. Really short. Thank you for your time. Any questions?
Well, I guess the computation is happening server side, especially in a WebVR situation, right?
Yeah.
Would that mean, going back to your game example, it'd be achievable to have half a dozen independent AIs, for example, who don't know what each other know, that could interact with each other based on what you talk to them independently about? And
absolutely.
They might gossip with each other as well. And
yeah. So it could be any number, right? And they can all have different memories of your interaction. So it could be a strategic game where you interact with one together. They don't know what you're talking about, and you can actually create some pretty specific gameplay there. That's totally possible right now.
And being server side, does that mean that the user's computational power might be increased because the whole menu system isn't sitting on their computer? If you theoretically got an incredibly advanced structure of menus, could it maybe alleviate a bit of pressure of having to preload all those interactions onto them? Or?
So the cloud component is going to be different than the visual rendering on the device. So you still need a lot of power, and that's why WebVR right now I think is pretty basic because of that computational power. But as those little devices become super powerful, it will be, obviously, that rendering is going to be much more complex and it's going to render very fast.
Have you done any investigation with the web speech APIs? Because that does it all inside the browser.
Yeah, I've looked at the web speech API, and one thing I don't like about it is that you have to play with grammars. So I come from a speech recognition background at Nuance, and it's all about grammars, right? So the ASR systems, it's all grammar, so you've got to get familiar with that. It's not great. So the way I prefer actually is to just capture the audio, stream that to an API that actually takes care of all of the stuff. So for example, the service that we've built, it's all in the server side. You can just send audio, waveforms, goes and does the transcription.
What's the latency on that?
I'm sorry?
Latency on that. What's the latency on that?
Well, it depends on the bandwidth for your device, right? So obviously you wouldn't be talking for long periods of time, so you'd be simple commands, simple interactions. So I haven't tested latency specifically, but as we've seen, just a simple command through a device can actually be pretty quick. So if you have a high performance NLU engine, we're talking about milliseconds. So the one we built is hosted in Amazon services, and we've got a custom built EC2 environment, and it's just a few milliseconds to get a response back. That's totally doable for WebVR.
Which speech API do you get the best results from currently?
So what, sorry?
Which speech API do you get the best results from currently? Because there's quite a few different competing.
Yeah, I think the Google speech API is pretty good.
Right.
Yeah.
Okay, have you tried the Microsoft one?
Yeah, it's pretty good also, but I think I haven't done analytical comparisons, but the Google one looks better.
Okay.
Yeah.
Because I read the other day that you're beating some record with the Microsoft one.
Yeah, it depends on the version.
translation or something like that.
The what?
Beating the human translation.
The translation has this is a
Yeah,
different topic. So both Microsoft and Google are debating, or not debating, but competing very hardly on that space. So they've both developed a new technology which is called neural machine translation. So it's a deep learning approach to translation, which is entirely different to how it used to be done before. That is, if you look it up on Google and read the publications, that is nice stuff. And it costs them so much just to build the system and train it. It's incredible. It's pretty exciting.
Have they done anything yet? I haven't seen it yet, but I'm assuming it's coming. Of caching stuff locally. So like how you've got the back and forth, right? Of kind of giving it commands. But has anybody done stuff to say cache with a common command? So if you were doing like a game or something, you're telling AI, hey, go here. If it's heard you say, hey, go left before, is it possible to then cache that and say, we already understand when you say go left, that's what your voice will sound like, to kind of reduce having to keep going back to the prompt?
That's an interesting question. I haven't seen any case of that. So the problem with that is to extract the intent, you need to process it through the NLU engine, and that's computationally very intensive. So I can't imagine having that on device. However, with some advanced neural network methods, more and more you can actually create models that are actually portable. Now are actually fitting on mobile devices. So
That could work then.
it could be actually doable. It's just the problem with the API of accessing that on the device. I don't know. Big question.
Cool.
More a comment. Both the games in Her were made by, it's more an acknowledgement actually, animator David O'Reilly, Irish animator, and I very much encourage people to check out his work. Please Say Something is excellent, and he also directed an episode of Adventure Time. He's very cool. His stuff's online.
Yeah, it was amazing. I mean, good work. Yeah. All right. Yeah, love it. Thanks. Broken. Sorry.
Alright, it won't come up on screen. I'll just be 1 second, sorry guys. Alright, let's call this a 5-minute interval while I fix my computer. We'll wrap up. Sorry everyone.
That's okay.